As our tools, we only have the number line, which is the main way to actually show or use our ranges for inequalities. So basically, the number line a, b, all the way to n, right, depends on the values that you get, or depends on the range of values that you have. So empty circle, shaded circle, empty circle being exclusive, shaded circle being inclusive. So these are the three ranges you'll get for the three different types of ranges of values or solutions. Then we use that for simultaneous inequalities. So let's say if our two equations are x plus 3 less than 4 or x minus 2 greater than or equals to minus 5. We then solve both inequalities to give us x less than 1 and x greater than or equals to minus 3. So we then put the ranges, right? So we put the solutions. So we have empty circle less than 1 and then shaded circle more than or equals to minus 3. Then we then get the intersection to give us minus 3, 2x, 2, 1. Polynomial inequalities, basically just factorize them if possible to give us x minus a, x minus b all the way to x minus n, really depends on what n is. But instead of the range of values, right, instead of putting the exact solutions, we'll be putting the critical values in our number line instead, which is basically the f of the value will give us 0. We then have calculate the plus or minus between each intervals, then solve the inequality. We then move on to our quadratic, which is a specific example. So if you get a quadratic equation, simply just factorize it, if not complete the square. But if you're looking at a factorization, you use the classic shape u or n, we then solve from the graph, right? So x less than or equals to 1 or x greater than or equals to 2. So usually if it's greater than or equals to is basically above the x-axis, less than or equals to is below the x-axis. We then move on to a subset of the polynomial, which is the polynomial fractions. So let's say we have this general case, and the idea is that you cannot just cross multiply, you must make them into a singular fraction where we have the denominator being the same on both sides, and then you do your minus or subtraction, right? The idea is that you want to get the inequality to be less than or equals to less than or greater than 0. All right, same thing, put your critical values number line where the denominator gives you 0 or the numerator gives you 0. And then you calculate again plus minus between the different intervals. We then move on to modulus in our inequality. Basically, the idea is that if you have mod fx less than k, where k is a real number, we then have fx less than k and fx greater than negative k. All right, you can actually think about this very logically. So if fx is more than k, mod fx more than k, fx is greater than k, and fx less than negative k. So it really depends on the inequality sign. So this is an example, mod x plus 3 greater than 1, you'd have x greater than minus 2 and x less than minus 4. We then move on to the last technique, which is the substitution, where if we have fx less than 0 and the solutions are x less than a, x mod than b, f mod x less than 0, just substitute every x with mod x, and that's it. If you substitute x with sine x plus 1, just substitute sine x plus 1 in the solution. Common substitutions are c power x, where c is a positive real number, you know that cx is greater than 0. If you substitute with x power 2n, like x squared x power 4, and n is an integer, positive integer, x power 2n must be greater than 0. So this is important because you then need to reject the relevant ranges, basically the negative values for both the first and second substitution, and 0 for 1.